About to start our section on chapter 1.9. And as always, when we start a section, we always start with the goal for the day. And the goal for today, or the learning target for today, is to solve equations using the subtraction and addition properties of equality. We've got a few new vocabulary words that we need to cover. The first one is the word solve. To solve is to find the value of the variable, the number that makes the equation true. That value is called the solution, or the answer, the solution. And inverse operations are pairs of operations that undo each other. This is not a new term. We've talked about inverse operations before. Addition and subtraction are inverse operations of each other, as is multiplication and division. They, in a way, cancel each other out. So here's an example. If we look at the equation that says 7 equals 7, that's obviously a true statement, but think of this as like a teeter-totter or a seesaw that's in balance. Well, whatever I do to one side of the equation, I have to do to the other side of the equation to keep it in balance. So if I'm going to say subtract 4 from this side, I also have to subtract 4 from that side. Or if I change the number 4 to 3, 7 minus 3 is of course equal to 7 minus 3, and the answer is 4. Well, think of that in this case where we've got an unknown here. If I want to keep this teeter-totter or equation in balance, whatever I do to this side, I have to do to the other side. So x plus 4, and I'm going to subtract 4 from that side. So I've got to subtract 4 from the other side. These two are inverse operations of each other, so they're going to cancel each other out. And of course, 6 minus 4 is 2. All right, well, let's do this in a practical example. We can solve x is equal to 15 plus, 7 is equal to 15 plus x. To work with this, I need to get the x all by itself. So I'm going to subtract 15 from both sides, because these are inverse operations of each other. So 15 minus 15 is 0 plus x, which of course is just x. And here 7 minus 15, well, I got to make that into an addition problem. So it's 7 plus a negative, 7 plus 7 minus 15 becomes 7 plus a negative 15. I take the larger one, subtract the smaller one, which would give me 8, and I take the sign of the larger one, so it's negative 8. So negative 8 is equal to x. Negative 8 is equal to x. If we move on down and do the same kind of thing here at the bottom, I'm going to subtract 11 from both sides. So these will cancel each other out, leaving just a. And I got 6 plus a negative 11. 6 plus a negative 11, I take the larger one minus the 6. So 11 minus 6 is 5, and of course I take the sign of the larger one, so the answer is negative 5 is equal to a. On the same token, if I subtract something from both sides of the equation, which is what we just studied, now I'm going to look at adding something to both sides. Again, my teeter-totter example works perfect. My seesaw's got to stay in balance. So if I've got 7 on this side and 7 on this side, if I'm going to add something, I have to add it to both sides. So in this case, I'm going to add 3 to both sides, and I'm going to get 10 is equal to 10. And of course, we maintain our balance. So here I've got x minus 5 is equal to 6. That's still on my teeter-totter, my seesaw. So I'm going to add 5 to both sides. These two are inverse operations of each other, so they're going to cancel out. I'm going to say x then is equal to 6 plus 5, or 11. Let's do a word problem, same type. If Carlos makes a withdrawal of $15 from his savings account, the amount in the account will be $47. So I'm going to make a withdrawal that indicates subtraction of $15. After that, the balance is 47. So I'm going to say then that the balance beforehand minus the $15 was equal to 47. How can I solve this for the balance? Well, inverse operation here, I can add 15 to both sides. These two 15s cancel each other out. I'm left with just B on this side, and that's equal to 47 plus 15, 12, $62. So B is equal to $62. Here's an equation already written out for us, ready to solve. I've got a -5. Teeter-totter is equal to Z minus 16. Well, to get Z all by itself, I'm going to add 16 to both sides. All right, these two are inverse operations of each other, so it becomes 0. Z plus 0 is just Z. -5 plus 16, it's an addition problem, but I take the sign of I take the larger one, subtract the smaller one, I get 11, and use the sign of the larger one, which is positive. So I say Z is equal to 11. Working on this bottom one, I can see it's very similar. I still have the teeter-totter, right? And I say -6 is equal to x minus 12. To keep things in balance, I'm going to add 12, but I'm going to do it to both sides. Both sides. These cancel each other out. They're additive inverses of each other, so I can say x then is equal to -6 plus 12. 12 minus 6 is 6, and I take the sign of the larger one, which is positive, so I would get plus 6.